Hello everyone, welcome back. So in today's lesson, we're going to cover through 1003, which is the sides and volumes of similar solids. Now so far we know that similar solids have the same shape, they have matching angles of equal sides, and they have matching side lengths in the same ratio. Okay, so that's something that should be quite clear. Now I'm just going to pick some of these questions just as a prep quiz so that it becomes clear what we need to do for today. So as you can see, these rectangular prisms are similar. Okay, as you can see, Q is just a bigger version of P. Now the first question is, what is the ratio of DC to KJ? Okay, so I'm just going to take out the notepad. Let's take a look. So DC is this length here, which is the XL. So the ratio should be XL to what? What is KJ? KJ is YL, right? So it's basically comparing these two lengths. So XL to YL. Now you want to simplify this because there's L for both. So you just divide both sides by L, you get X to Y. And that's question 1 done. Question 2, what is the ratio of CE to JL? CE to JL, well, that's probably going to be the same. So XB to YB. So XB to YB. And divide B to both sides, you get X to Y again. Next question says, what is the ratio of area ABCD and area HIJK? Okay, so what's the area of ABCD? Okay, well, we know that DC is the XL, right? And we know that BC is XH. So then the area of ABCD is XL times XH, which is X squared HL. And the area of HIJK is what? Well, what's KJ is YL. The IJI is YH, so YL times YH is Y squared HL. You simplify this, you get X squared to Y squared. Right, and this does not surprise us because we already learned that if the ratio of the sides of two shapes is X to Y, then the ratio of the areas should be X squared to Y squared, and that's correct. Now the next question is something the next one is still going to be an area question, so let's just do it. Question 4. What is the area of BCEF? BCEF. So BCEF is this shape here. So BC is XH, CE is XB. So then XB times XH is the X squared BH. To what? IJLM. So IJLM is what? So the IJ is YH. And then JL is YB, so then Y squared BH. So if you compare these two surfaces, it's also going to be X squared to Y squared, right? Now the last one is what we're going to learn today. What is the ratio of the volumes? And as you probably would have guessed, the volume is just going to be the cubed version of this, okay? But we can just test it out. So volume P. So to work out the volume of P, you have to multiply the three sides. So DC, CE, and CB. So if you multiply all these three together, you should get X squared LBH, right? And if you multiply these three sides, you get Y squared LBH. I mean, sorry, not Y squared, Y cubed. This should be X cubed LBH. And you divide both sides by LBH, you get X cubed to Y cubed, right? So here I'm just proving to you that the ratio of the volume should be X cubed to Y cubed. And that's something you probably would have expected, okay? All right, so then let's just take a look at the first worked example. Two cubes have a length of matching edges in the ratio of 4 to 3. Find the ratio of the areas of matching faces. Okay, so we know that the length of the sides is going to be 4 to 3. Then the ratio of the areas is just going to be 4 squared to 3 squared, right? So which is 16 to 9. The volumes, you just have to cube it instead of. So then the volumes is just going to be 4 cubed to 3 cubed, which is 64 to 27. So it's pretty straightforward, right? Because volume is 3-dimensional, area is 2-dimensional. Okay. Now let's look at the next question. Two similar statues were made at Naomi's studio. Okay, so I'm just going to put this up again. I'm going to put it here so I can do it. Alright, two similar statues would be to be made at Naomi's studio. She first completed the small one and painted it with a special gold paint. the smaller statue was 1.6 meters, had a volume of this, and needed this much gold to paint. Okay, what volume will be the largest that you have if it's 2 meters tall? Okay, so normally when it comes to questions that have the word paint, the first thing you should think of is surface area, because normally paint is area, right? So let's just write down the ratio of the sides first. The ratio of the sides. What's the ratio of the sides? So we know that the ratio of the smaller one is 1.6, and the ratio of the big one is 2, right? So 1.6 to 2. So then, what volume would the largest statue if it was to be 2 meters tall? Okay, so then we have to work out the ratio of the volumes, right? So then to work out the ratio of the volume, we just have to cube both these values, right? So 1.6 cubed and 2 cubed. So what's 1.6 cubed? So we just type it into a calculator. 1.6 cubed. 4.096. Okay. So then it'll be 4.096 to what? 2 cubed. 2 cubed is just 8, right? Right. So the ratio of the volumes is 4.096 to 8. Now we have to work out what the volume. So we want to know what the volume of the smaller statue is, and it says it has a volume of 0.384 meters. Okay, so this is actually a typo. It should be 0.384 meters cubed. So we write 0. So for the smaller one, make sure they are aligned correctly. If the smaller one is 0.384, then what should the big one be, right? So because we already have the ratios, we can just match them and solve for x. So x equals to 0.384 times 8 divided by 4.096. And what should the answer be? Just use your calculator for this. So you get 0.384. Now remember, this is just the trick. You don't actually have to type the 0 when it's 0 point something. You can just type a point. Times 8 divided by 4.096. You get 0.75. So then make sure you write the units. Now the units should be in meters cubed because it's volume, right? So this is actually a typo. And let's just check the answers. As you can see, 0.75 meters cubed. Okay. Now the next question says, how much gold paint will be required to give the largest statue 2 coats? So we know that when it comes to paint, it's to do with the areas. So to work that out, you need to know what the ratio of the areas are, okay? So the ratio of the area is going to be what? 1.6 squared and 2 squared, right? So what's 1.6 squared? Well, that's 2.56 to 2 squared, which is 4. So once you figure out the ratio of the area, then you can just work out the gold paint. It says how much gold paint will be required to give the largest statue. So we need to already know what the smaller one is, and the smaller one is 400 mils. Right, so then if the smaller one's 400 mils, what should the big one be? Okay, so then to solve for x, just do x is equal to 400 times 4. You can just use the cross method. Right, so like this, it's the same as how I did this question as well. Times 4 divided by 2.56. And what does this give you? Let's see, 400 times 4. $625. So then it should give you 625 mils. That's what's required. That's how many mils of paint is required to paint the largest statue, and check the answer. As you can see, 625 mils. Okay, so just remember, when it comes to doing these questions, make sure you write these out clearly. Ratio of the sides, ratio of the areas, and ratio of the volume. So ratio of sides, you always need to start off with this when they give you these questions. To get the ratio of the areas, you have to square them. To get the ratio of the volume, you have to cube the ratio of the sides, right? Okay. So let's take a look at some of these questions. So in each of the the solids are similar, find the ratio of the matching the areas. Okay. So you already know what the ratio of the sides are. To just find the ratio of the areas, you just square them. And to find the ratio of the volumes, you just cube them. And then because in this question it says smaller to larger, so you have to write the smaller one first. Okay, so what that means is this. So for 1a, part 1, what you want to do is write the smaller one first. So that means the ratio of the sides is 40 to 60, right? So then the ratio of the areas is going to be what? 40 squared to 60 squared, which equals to 1600 to 3600. Now, when you get to this step, make sure you simplify this, okay? So you can simplify this to what? You can type it into your calculator just to make it easier. So 1600 divided by 3600. Turn into a fraction, so 4 to 9, right? Actually, it's probably better that you simplify this to begin with, so that the ratio of areas will just become clear. And then the ratio of volume is equal to 40 cubed to 60 cubed. Now, what you can do is just type this into your calculator just to make it easier, so you don't have to simplify in your head. So what's 40 cubed divided by 60 cubed? 8 to 27, right? So that's your answer. Alright, so question 1 is pretty easy. I'll move on to question 2. Alright, so let's see. 2. In 1a, the area of the base of the smaller is 780. Find the area of the base of the larger solid. Okay, so basically, once you find out the ratios of the areas, just use the cross method and you get the area. And that's the same with 2b. Find the ratio of the volume, use the cross method to find the volume. Alright, so let's take a look at question 3. So I have a feeling question 3 is just doing the questions in reverse. So in each part, the solids are similar. Find the ratio of a side of the smaller solid to the matching side on the larger solid. Hence, find the ratio of the surface, the areas. Okay, so in this question, they give us the volume first. So because they give us the volume first, we have to work backwards. Okay, so let's just do it. So 3a. So they give you the ratio of the volume. So the ratio of volume is what? 125 to, is equal to 125 to 343. Now, the question says find the ratio of the side. So then just do ratio of side. Now to go from volume to side, you just take the cube root, right? So cube root of 125 to the cube root of 343. So this should I think this should just be 5 to 7 if I remember correctly. Okay, so then the next question is says hence find the ratio of the surface areas. So then once you work out the side, you can just work out the area. What is 5 squared? 25. What is 7 squared? 49. Right. So that's how you can do 3a. So it's pretty straightforward, right? Basically, you're just working backwards. Rather than going from side to volume, you're doing volume to side. And then question 4a. Let's take a look at 4a. So in question 3a, the surface area of the solid P is 63. So that means the smaller one is 63. Find the surface area of solid Q. Okay, so we know that the ratio of the areas is 25 to 49, as indicated by here, right? So then we know that the surface area of P is 63, so the smaller one is 63. What should Q be? Basically, right? So just use the cross method. So X is equal to 63 times 49 divided by 25. That should give you what? So 63 times 49 divided by 25. So it should give you that number here, 123.48. And this should be in centimeters cubed. Oh, it's centimeters squared, right? Because it's the surface area, right? Alright, so that's question 4. Let's look at some of the harder questions now. But basically, all these questions are kind of the same thing. So I'm just going to pick a hard one here, okay? So I'm just going to pick question 10. Okay, so let's just take a look at question 10. So it says a model is 1/32nd of the real object's height. Complete the surface area of the model. Okay, alright. So then, basically what you can just do is this. You can just say a model and then real object. So it says the model is 1/32nd of the real object's height. So if the model, so that means the ratio of the sides should be what? So say if the side length of the model is 1, what should the side length of the real object be? It should be 32, right? Because the object, actually, we don't really need this. Because we know that the model length is 1/32 of the real object's height. So if the model is 1 centimeter, then the real object should be 32. So that's the ratio of the sides, comparing the model to the, I guess, the real object. Alright, so then, now question A says, the surface area of the model is what of the surface area of the real object? Okay, the surface area, so you just have to find the ratio of the area, right? Is equal to, you square the 1, and then you square the 32. So, what's that equal to? So 32 squared, 1024. Okay. So then that means what? That means the ratio, the surface area of the model is 1 on 1024 of the area of the object, right? Part B. And then it just asks you the volume. Okay, so the volume, so you just have to cube what the 32 is. So then the ratio of the volume is equal to 1 cubed is 1, 32 cubed is, okay, what's 32 cubed? Okay, this is a pretty big number, 32768. So that means the volume of the model is 1 on 32768 of the volume of the real object. Yeah. And the question in part C is, if the object has a volume of this, what would be the volume of the model? Okay, so that's pretty straightforward, because from part B it says the volume of the model is this number times by the volume of the real object. So then when they give you the volume of the object, you just have to multiply by this number to get the volume of the model, right? So then the volume is equal to 90,000 times by 1 on 32768. And what should this give you? 90,000 times 1 on 32768. 2 decimal place, so 2.75 centimeters cubed. Right? So that's a pretty big difference. That's the volume of the model, and that's the volume of the object. Okay, so I think that should be most of the questions I've covered. Now, I'm not going to cover through all of these, but I believe most of these questions are kind of similar. You just have to read the questions carefully. So from now on, if you see a question that says something like paint, just think of it as surface area, because paint is, you only paint on the outer surface. So that's a pretty useful trick if you don't know that already. And I think that should be all. Okay, thank you for listening.